How do we know the universe is expanding? Well, the idea that the universe is getting bigger often comes from thinking about where it started. If the universe started in the Big Bang, as we believe, then ever since this point it has been increasing in size, powered by the huge initial temperatures and energy. But how do we know that it's expanding? What evidence do we have? Well, we can actually see and measure the movement of other galaxies in our universe. But how? Well, as with most things in astronomy, we rely on light, the light being emitted by the billions of stars inside each of these galaxies. When we measure light, we mainly look at its colour or wavelength. The wavelength is the distance from one peak in the wave to the next. The length of a wave defines the colour we see, with shorter wavelengths being blue and longer ones red. Of course, these are just the colours that our eyes can see. There's also a lot of light outside of these wavelengths, like radio waves, X-rays, and microwaves. Now, sometimes the wavelength of light can change. If the wave gets stretched, it turns redder with a longer wavelength, and if it gets squashed, it gets bluer with a shorter wavelength. It might sound strange to have waves getting squashed and stretched, but we come across this phenomenon a lot on Earth, only with sound waves. We call it the Doppler effect. Imagine, if you will, standing on the pavement when you hear the noise of a lorry approaching sounding its horn. As it gets closer, the pitch of sound gets higher, and as it moves away, it gets lower. This is because the sound wave is being squashed between the moving vehicle and your ear as it gets closer. The squashed wave has a shorter wavelength. With light, we see the colour change. With sound, we hear the pitch change. It gets higher. Then, as it moves away, the wave is stretched between the moving vehicle and your ear, making the wavelengths longer or lower pitch. In space, on large scales, we see this phenomenon with light, and we call it cosmological redshift. When we look at other stars and galaxies in the universe, we see changes in the light emitted from them. Some of our closest galaxies, like Andromeda, show bluer light than we expect. This is called blue shift, and occurs because the wavelength of light emitted by Andromeda is squashed as the galaxy moves towards us. We are being pulled together by gravity. But when we look further away, out into space in every direction, we see the opposite. Galaxies whose light appears redder, redshifted light, caused by the wavelengths being stretched as the galaxies move away from us. But how do we see this? How do we measure it? We use the spectrum of light. The light from each galaxy is spread out into its entire range of wavelengths, much like passing white light through a prism. The spectrum from a galaxy shows the different colours of light, but imprinted over the top are lines. Dark lines where the light has been blocked or absorbed by dust or gas, and bright emission lines where specific elements like hydrogen and nitrogen have produced light. Each of these patterns of lines acts like a fingerprint for the chemical element which has produced it. So when we look at a galaxy spectrum, we can pick out these individual fingerprints, and we can see how much they've moved from where we'd expect to see them here on Earth. The bigger the shift, the further away the galaxy is, as the light has had longer to travel, stretching the wavelength all the time. This is cosmological redshift, the movement of these lines towards the redder part of the spectrum. It doesn't happen on small scales, only big. The light has to travel really far for us to see the effect. It was first seen by Hubble in 1929. Before then, we didn't even know the galaxies existed. So we know that gravity is the force pulling nearby things together on small scales. But what is making them move away? What is the force acting to push galaxies apart when we look further away on large scales? Galaxies all sit on and in a grid, the fabric of the universe that we call space-time. This fabric can move. It can be vibrated if there is a large explosion nearby, like two massive stars colliding. We call the vibrations gravitational waves. But the fabric itself is also being stretched. The space between objects is getting bigger as space-time gets bigger, powered by the initial explosion of the universe in the Big Bang. Today, we not only know that the universe is expanding, we know that the expansion is accelerating. The universe is moving faster today than it was billions of years ago, but we don't know why. We call this force, which is accelerating the expansion, dark energy. It was first predicted by Einstein over 100 years ago, and although we now believe that it really exists, we do not know what it is. There are so many questions we still have about the universe, but there are some we can answer. If space-time is expanding, is everything inside it expanding too? No. The forces which expand the universe only work on really large scales. They can't change things on small scales. The forces holding together the molecules in our bodies, stars, and galaxies are much stronger, so objects themselves don't get bigger, just the space between them. How fast is it expanding? We call the speed of the universe the Hubble constant. It isn't really constant at all. It changes with time. So the speed 10 billion years ago isn't the speed of today. Today, the Hubble constant tells us that the universe expands by almost 7% every billion years. Why is everything moving away from us? It isn't really that everything is moving away from us. Everything is moving away from everything else. No matter where we lived in the universe, we'd see the same thing. We sometimes call it our observable universe, the version we see from our position. From here, it looks like everything is moving away from us, but if there was life in another galaxy in the universe, it would look the same to them. Okay, but what is it expanding into? Now, this one is tricky to understand. We all live on this fabric of space-time, connected as part of the universe, but there isn't space outside the universe. Our whole universe exists on this fabric, so as far as we know, we're not expanding into anything. Nothing exists outside of our space-time. So there's a quick view of this huge subject. It might have left you with more questions. How can we find out about dark energy? What if there are other universes? Well, maybe one day it will be you who finds out.